Welcome to the deep dive. You've sent over a stack of material on data modeling research.
Yeah, she's some handwritten notes.
Yeah, we're going to untangle it all, and by the end, you'll see how relevant data modeling is.
Even if you aren't a tech expert, it's like the secret sauce behind how companies actually use all that data they keep collecting.
Ready to become your office's data modeling guru?
Guru might be a stretch.
Okay.
But you'll definitely understand why companies who get this right are the ones winning the data game.
Okay, so first things first.
For anyone who's not totally immersed in the data world,
what is data modeling, and why is it so important?
it's essentially creating a blueprint for your data, like an architect's plan for a building.
Okay.
But instead of walls and rooms, we're talking about customer information, sales transactions, product, details, all those digital building blocks that make a business run.
And a good data model keeps things from turning into a data dumpster fire, right?
Exactly. Without it, you end up with inconsistent data. Difficulty accessing what you need and projects that stall because no one can agree on what the data actually means.
One of the sources even mentioned a program that completely imploded because the data modeling was so bad.
Oof.
That's a cautionary tale if I've ever heard one.
Yeah.
So who are the people creating these all-important blueprints? Who are these data modelers?
There are special breed strategic thinkers who can speak both the language of business and the language of technology.
Wow.
They translate those complex business needs into a structured, efficient data model.
Sounds like they need a serious blend of skills. Is there a certain type of data modeler that companies should be looking for?
You've hit on a key point from our sources.
Okay.
The need for what they call a master modeler.
Ooh.
This is someone who's not just proficient in the technical aspects, but also a leader, a mentor, someone who can really champion data modeling within the organization.
So they're like the data modeling Jedi Master.
Yes.
Now, our sources break down data modeling into three key sub-capabilities: meta-modeling, conceptual or logical data modeling, and physical data modeling.
Right.
Let's unpack these a bit.
Let's do it.
Starting with meta-modeling.
Sure.
What exactly is that?
Think of it as setting the ground rules for your data.
Okay.
Meta-modeling ensures everyone across the company speaks the same data language. Let's say you have customer data marketing might define a customer differently than sales or customer service.
Right.
A meta model makes sure everyone is on the same page, avoiding a ton of confusion down the line.
So it's like establishing the official dictionary and grammar guide for your company's data, making sure customer means the same thing in every department.
Yes.
That's got to save a lot of headaches.
Absolutely. It ensures consistency and clarity from the very beginning, which is crucial for building reliable data systems.
Okay, so meta-modeling sets the foundation.
Yes.
What happens next?
We move into conceptual and logical data modeling.
Okay.
Here's where we start mapping out the relationships between different data concepts.
Got it.
Think about domains like customers, employees, and products.
In one of the articles, there's a great example about transactions, showing how each transaction links to a specific customer. The products purchased, the payment method, even the store location.
Right.
It really highlights how interconnected everything is.
Exactly. The conceptual model captures those high-level relationships, and then the logical model adds more detail.
Okay.
We specify data types, define keys that connect different pieces of information, and list the attributes we need to track, like a customer's name or a product's SKU.
So we're adding layers of detail to our data blueprint.
Yeah.
And then the final stage is physical data modeling.
Correct.
Is this where we get into the nitty-gritty technical stuff?
Precisely.
Okay.
We take that well-defined logical model and translate it into specific database schemas.
Okay.
We're defining tables, columns, indexes, all the technical instructions needed to actually build the database.
Yeah. So if the logical model is the architect's blueprint, the physical model is the contractor's detailed construction plans, making sure the data building is actually built correctly and efficiently.
A perfect analogy. And just like a contractor needs deep expertise in building materials and techniques, this stage requires specialized skills in database systems to ensure everything works smoothly and can handle the company's data needs.
Okay, so we've got the blueprint and the construction plans.
Yes.
Now, how do we know we're doing this data modeling thing well? Our sources talk about achieving high maturity in data modeling, and they break it down into 5 key dimensions.
Okay.
strategy people and talent processes, technology and adoption.
Right.
Can you walk us through each of those dimensions?
Absolutely. It all starts with strategy.
Okay.
Data modeling shouldn't happen in a vacuum.
Right.
It has to align with the overall business goals and objectives.
Hmm.
The question isn't just how do we organize our data,
Right.
but how can we use data to achieve what we want as a company? For example, if a company is focused on improving customer experience, their data model needs to support that goal, making sure they can access and analyze customer data effectively.
So data modeling isn't just a technical exercise.
Yeah.
It's deeply tied to the business strategy.
Yes.
And that brings us to the people involved.
Right.
What makes for a strong data modeling team?
We've already talked about the master modeler as a key asset,
Uh-huh.
but beyond that individual, you need people who understand the business,
Yeah.
have strong technical chops, and are excellent communicators.
Okay.
They need to bridge that gap between departments,
Yeah.
translating business needs into technical solutions.
And having clear roles and responsibilities is critical, right? Making sure everyone knows who does what and avoiding those stepping on toes situations.
Absolutely. Clarity and good communication are key for any successful data modeling effort.
All right, next up is processes.
Okay.
I have to admit, processes don't always sound like the most exciting topic,
Right.
but I suspect they're incredibly important in this context.
You're right. They're often overlooked, but they're the foundation for consistency and efficiency. We need documented methodologies, standardized templates, quality control checks, a structured way of doing things that ensures high-quality models.
Got it.
Think of it like a recipe. Having a clear process helps everyone create a consistent data dish, even if different people are involved.
So instead of relying on individual heroics, it's about having a system that works reliably no matter who's doing the work.
Exactly. And then, of course, we can't forget technology.
Okay, let's talk tools. I'm guessing there's specialized software that can help with all these different stages of data modeling.
There is. We have data modeling tools that help visualize the models, generate database schemas, even simulate how the database will perform under different conditions.
And what about those data catalogs and business glossaries you mentioned earlier?
Yes,
Are those considered tools in this context?
absolutely. They become essential as data models grow more complex.
Okay.
Data catalogs act like a map to your data landscape, helping you find and understand the data you need.
Right.
And business glossaries maintain a central repository of definitions, ensuring everyone is using terms consistently.
Got it.
These tools can really boost collaboration and prevent misunderstandings.
So they're like the search engine and dictionary for your data, keeping things organized and accessible?
Yes.
And finally, we come to adoption.
Okay.
This is about actually using those carefully crafted data models, right?
Exactly. It's about weaving those data modeling practices into the everyday fabric of the organization.
Okay.
This might involve training programs, communication campaigns, even incentives to encourage people to use the models correctly.
So it's not enough to have a beautiful data model sitting on a shelf.
Right.
You need to get everyone on board and actually using it.
Exactly. And that's what achieving a high level of data modeling maturity looks like. Strategy, people, processes, technology, and adoption all working together seamlessly.
Wow, that was a fantastic overview of the key dimensions. I'm starting to see how all these pieces fit together to create a data-driven organization.
Yeah.
But our sources don't just stop at theory, right?
They do not.
They actually give some great practical tips and best practices for making data modeling work for you,
Right.
not against you.
Exactly.
They emphasize starting with a strong meta model.
Absolutely.
Remember, it's the bedrock of everything else.
It is.
One source even described trying to align incompatible models later on as a
Gargantuan task.
gargantuan. Definitely sounds like a data modeling nightmare.
Yes, it does.
So meta model first check. What else do they recommend?
They highlight the value of pre-built industry models.
Okay.
Depending on your industry, there might be existing models that can save you a ton of time and effort. For example, BN is a well-established model specifically for the banking industry.
So instead of building everything from scratch, see if there's a model that already aligns with your industry needs. Kind of like using a proven recipe instead of experimenting with random ingredients.
Exactly. It can be a huge time saver and help you avoid common pitfalls. Another tip is to take a phased approach, iterating between the different types of models.
Okay.
Don't try to tackle everything at once. Start with a few key domains, get the logical model solid, then move to the physical model for those specific domains and gradually build out from there.
So focus on building a strong foundation first, then expand outwards, right? kind of like building a house room by room.
That's a great way to think about it. And when you get to the physical modeling stage,
Yeah.
don't feel the need to overcomplicate things.
Yeah.
Focus on documenting the mission-critical systems and details rather than trying to capture every single nuance.
Keep it streamlined and avoid getting lost in the weeds.
Yeah.
Makes sense. Now, they also talk about being strategic with technology.
Yes.
What does that mean in the context of data modeling?
It's about choosing the right tools for the job at the right time.
Okay.
As your data models grow and evolve, you'll likely need more sophisticated solutions like data catalogs and business glossaries. But don't implement them prematurely.
So start simple and scale up your tech stack as your data modeling maturity increases. Don't overspend on tools you might not need right away.
Exactly. Now, we've mentioned the master modeler a few times now.
Yeah.
And this role seems crucial to getting data modeling right.
Mm-hmm.
Can we delve a bit deeper into what makes a master modeler?
I'm really curious about this too. What sets them apart from other data modelers?
It's more than just technical skills.
Okay.
They have a deep understanding of the business, a knack for identifying and defining best practices, and the ability to create reusable assets like templates and guidelines that can benefit the entire organization.
So they're not just creating models, they're shaping the entire data modeling culture within the company.
That's right. They're leaders and mentors who champion data modeling, ensuring quality, consistency, and a continuous improvement mindset. They're the glue that holds everything together.
Okay, we've covered a lot of conceptual ground here,
Yes, we have.
but I think a practical example would really help solidify all these ideas.
I agree. Let's walk through a simplified scenario.
Okay.
Let's say we're working with a retail company. We can start by looking at how a meta model might define some key concepts.
A retail example is perfect. Everyone can relate to shopping and buying products. So how would we approach defining these concepts in a meta model?
Well, first, we'd need to think about what customer means for this particular retail company.
Okay.
Do they include online shoppers, in-store shoppers? Do they differentiate between individual customers and business customers?
Got it.
We need to establish clear definitions that everyone agrees on.
And the same goes for product.
Exactly.
Are we talking about physical goods, digital downloads, services? You need to make sure a product has a consistent meaning across all departments.
Exactly. And then we'd move on to defining the relationship between those entities. How do customers interact with products? Through purchases, wish lists, reviews. We need to map out those connections and ensure everyone is using the same language.
So the meta model is like a blueprint for how we talk about data, making sure everyone is speaking the same language from the very beginning. And once we have that foundation, we can start building out our conceptual and logical models.
Right. Let's imagine we want to model the sales domain for this retail company.
Okay.
At the conceptual level, we'd start by identifying the key entities. We'd have customers, products, transactions. Those are the core elements.
And then we'd start mapping out the relationships between those entities.
Yes.
Customers place orders, orders contain products, and so on. We're creating a visual representation of how these concepts interact.
That's exactly right. We'd show how each customer can have multiple orders. Each order can contain multiple products, and each product can be part of multiple orders.
And as we move to the logical model, we start adding more details to those entities and relationships, right?
Absolutely. For customers, we might specify attributes like customer ID, name, address, email, and purchase history.
Okay.
For products, we'd have product ID, name, description, price category.
So we're fleshing out those entities with more specific information that's relevant to the business.
Right. And we'd also define the types of relationships between entities more precisely.
Right.
We might specify that a customer can place many orders, but each order must be linked to only one customer.
Got it.
We're establishing rules for how the data can be structured based on real-world business logic.
So the logical model is like adding detailed annotations to that conceptual map, making the relationships more precise and specific. And then finally, we translate all of this into the physical model, which is where those database experts come in.
Yes. At this stage, we'd define the actual database tables and columns based on the logical model. We might have a customers table with columns for customer ID, name, address, and so on, a products table with its own set of columns. And then, of course, tables to represent the relationships between them, like an orders table that links customers and products using human identifiers.
We're taking that blueprint and turning it into detailed construction plans, specifying exactly how the database will be built.
Precisely. And we'd also make decisions about data types, primary keys, foreign keys, all those technical details that ensure the database is structured correctly and can handle the company's data needs.
So we're taking a journey from abstract concepts to a concrete database implementation. And I have to say, it's fascinating to see how those different stages build upon each other, guided by that initial meta model.
That's the power of data modeling. It gives you a structured way to think about your data, to ensure its quality and consistency, and to ultimately use it more effectively to support the business goals.
It's like the foundation upon which a successful data-driven organization is built.
It is.
That was a great walkthrough. Seeing a concrete example really helps solidify the whole data modeling process. And, throughout all these sources, there's this recurring theme about the master modeler being so crucial for success.
It's definitely a key role. They're not just technical experts, but also leaders and mentors who can foster a data-driven culture across the whole company. That makes me wonder, how do organizations identify and empower a master modeler? Is it a title you just give someone, or is there more to it?
It's much more than a title. It's about recognizing individuals who possess that unique blend of technical expertise, business acumen, and leadership qualities. It's also about providing them with the support and resources they need to excel in this role.
So maybe it's about creating a clear career path for data modelers with the master modeler as a pinnacle role that could incentivize people to develop their skills and really embrace those leadership responsibilities.
That's a great idea. It's about recognizing the value they bring to the organization and investing in their growth. It's also about giving them the authority to champion data modeling initiatives, to set standards, and to guide others.
And thinking about our retail example, this master modeler would be the one ensuring that everyone from marketing to sales to inventory management is using the same customer and product definitions right.
Exactly. They'd be the guardian of consistency, making sure the data model is implemented correctly and used effectively across the entire company. Okay, so let's zoom out a bit. We've talked about why, the how of data modeling, and we even got into some practical tips and best practices. What do you think is the biggest takeaway for our listener today?
I'd say it's that data modeling isn't just a technical concern. It's a strategic imperative for any organization that wants to be truly data-driven. It's the foundation for everything else, from building reliable data pipelines to making informed business decisions.
And doing it well requires a holistic approach. It's about having a clear strategy, investing in the right people, establishing solid processes, leveraging the right technology, and ensuring widespread adoption. It's not a one-and-done project, it's an ongoing journey.
Exactly. And the organizations that prioritize data modeling and cultivate a data-driven culture are the ones that will thrive in today's data-rich world.
So for our listener who now has a deeper understanding of data modeling, I think the key question is, what's your next step?
Maybe it's about taking a closer look at your own organization's data modeling practices. Are you achieving that high level of maturity across those 5 key dimensions?
Or maybe it's about identifying potential master modelers within your team and finding ways to empower them. There's a lot to consider, but hopefully this deep dive has given you the knowledge and inspiration to take action.
And remember, the world of data modeling is constantly evolving. New tools and technologies are emerging all the time. So stay curious, keep learning, and don't be afraid to experiment.
That's great advice, and I have a feeling our listener is going to do just that. So until next time, happy modeling.